to Buildstream number 6. Today, we'll be meeting with Ryan and going over building a Tictactoe Rollup with the Shard-SDK. And Buildstream is a series where we're meeting with builders in the Celestia ecosystem to learn about what they're building and learning how to build with their tools. So as I mentioned, we're going to be learning how to build Tic-Tac-Toe with Shard-SDK by Prism. I'm happy to be joined today again by Ryan from Prism, and my name is Josh from Celestia Labs. If you have any questions during the stream, please add them to the chat and we'll get to them during the stream. And all the source will be available on GitHub after the stream in the description. Ryan, welcome again. It's great to have you as always. What are we going to be doing today?
Great to be back. So I made something along with my team at Prism. To give a little bit of context, we have this problem in our ecosystem.
Yeah.
And that is, if you want to make anything, like any type of rollup, the tooling is way too advanced. You need way too much context about, I don't know, a ton of things. And then rollups could be a lot simpler. And we noticed this when we were building Prism. And we were like, okay, well, there's no tooling to actually like create this.
Yeah.
Create a rollup like this, given the current rollup SDKs. And so something has been brewing like in the back of my mind since the beginning of this year, at an onsite with the Celestia team, where I said, okay, well, let's make a Greg SDK where it's like the most basic SDK you can make. There are no features, you do everything yourself, but the architecture is so simple because of the base sequencing that you only have to implement a very minimal interface to get your rollup. That's what we did last week. We like made this very crude V001 that I haven't shown anybody yet, and I made the first example with it this morning. And we have a lot of things we want to add to it, not necessarily like features, but we want to be able to let people make ZK rollups and then have the in-browser light node ship with it automatically. So anyways, I thought like, what is the most basic thing that I could make with you today? And I remembered that you made a really simple rollup recently.
Dumber version of a rollup.
Yeah. But it's a very good like idea for, okay, here's just a like decentralized app you could build, make a little rollup for that's super simple. And I didn't want to redo Greg Chat. Greg Chat is something that we made in a previous build stream.
Yeah.
So we're gonna make Tic-Tac-Toe as a rollup using this new tool. Like I said, it's very crude. If you could show my screen.
Yeah, and I guess like kind of it's taking a step back. It sounds like in-browser light nodes or something that's coming soon, TM, like within the next year at least.
Within the next
way sooner than that.
Like way sooner. Like
yeah.
The thing is getting in-browser light nodes to work with the ZK rollup is like it's already working. It's not working on Celestia mainnet, but it's working. We got it working at Prism.
Yep.
And now it's just going to be a matter of tightening up that integration, the API, and like letting users be able to, or letting developers be able to integrate with it more easily.
Nice.
So we made this Shard SDK.
I guess where I was going with that is it sounds like once we are able to use these, like using in-browser light nodes and using something like Celestia for DA, you basically have a fully decentralized application that runs in the browser and like validates all the information by using the light node.
Exactly.
Which I think is really cool.
Right. I want to get this out as soon as possible, like with the light node, because what it will enable for are like you have your rollup that's your light node is running entirely in the browser. You're verifying the chain yourself.
Yep.
Yeah, that's the dream.
Yeah, I guess validating was not the right word to use there. Definitely verifying.
No, it is. It's like validating is kind of a dirty word, and
it just like makes me think of validators.
Exactly. Yeah. But that works. So
you ready?
I think I'm ready. I'm sharing my screen. You could show that.
Yep.
F5. first. So I have
Nice.
this repo. I don't know if you can do it easily, but if you could post a link to Shard-SDK, it's
Yep.
just delta.de Shard-SDK. And this lets you make a really simple rollup. So I have already downloaded it. Well, of course, I already have it on my computer. So is this font size okay?
Yeah, that's good.
All right.
Yeah.
So we use just as a task runner. It's like make file. So you might have to do like root install just if you don't have it.
Cool.
But what you do is you clone this repo, you go into it, and then if I run just install,
Basically
it
like make
will,
install, right?
yeah, exactly.
Yeah.
It just installs the binary, and then I can now use that program, use the Rollup SDK. So we're going to do shard init, tic-tac-toe. Almost misspelled tic-tac-toe. And it creates a new Rollup project. So now I can go inside of there. And I can open it in my code editor. One sec. Let me switch to. Well, let me do this on a different window. I don't want to open my file system on my main window.
You're good. That's a reasonable thing to not do.
Um,
I'm gonna try at some point. Maybe I can play from my end. So I'm getting just
yeah.
installed, and I guess if there's anything else, I'll do it as we go.
All right. So this initialized the rollup, and it has everything you need. Like technically, we could already run this, but you'll notice that there are a few files here.
Can you zoom the text editor and just
Yeah.
one or two ticks? Yeah, thank you.
So we have, if I open transaction RS, you can see that we have no transaction types. Like we have one, which is a no op. And then an actual transaction has a few more fields. So this is different than the rollups we've made in previous streams because before it was just the enum. And now I have added signature verification for everybody. So
Nice.
if you want to use signature verification in your rollup, all you'd have to do is change this to true. But anyways, let's first think about what we want to make. So you have this repo, which is dummy rollup tic-tac-toe, which we're going to steal things from. And it's in a single file, but the actual transaction, I think, is we just post the position, right? There's no other fields.
There's no there's nothing except for basically posting the play and then reading it back.
Right. So what I want to make is I want there to be a system where you can create a game and then another user can join the game and then only those two users can send moves. Of course, the only user that can send a move is the person whose turn it currently is.
Yep.
And then we have, yeah, that's pretty much it. So that means that we have 3 transaction types. We have create game, which takes a string, which is like the game ID.
Name. Yeah.
Join game, which also takes the game ID. And then like those use your public key to like as your, I don't know, username, I guess.
Yeah.
And then to actually make a move, we have that as well. So if I go into this rollup, I can start adding those transaction types really easily. And maybe I can zoom in even a little bit more.
Yeah, that's good.
So I can say shard create tx. I think, let's say create game. And then it takes a game ID, which is a string. That's it, right?
This is sweet already.
So now we made that transaction type. And then now we need the same thing, but for joining a game. So join game, game ID, string. All right. And then the last one, because I said there's 3, is move, which takes a game ID, because you can be playing multiple games, and then a position, which is a U8. It's just a byte. Like it's it's a, what is it called? It's the index of the game board, I guess. So now we have all those, and if I switch back into my code editor, we'll see that I have the transaction types here. So one thing.
This is awesome. I haven't actually seen this before. Good work.
There's like some issues, like it removes all the white space. The macros are removing, or anyways.
Yeah, all good.
So let me think about what we're going to do here. I do want to add signature verification, so I'm going to set this to true. And
What kind
what
of
that means,
accounts is this going to use? Yeah.
yeah. So I'll go into that now. So like, if I where's my terminal? Let me install this binary cargo. Oops. Cargo install path. All right, this is probably gonna have to build first. So I built in the key system into the rollup. So while this builds, I guess I'll like explain. So I simply say like tic-tac-toe create signer player one. And then that's going to add a signer to my macOS keychain that will then be used to sign transactions when I use that key to submit them.
You said it's using your macOS keyring?
Yeah.
Okay, that's sweet.
It'll
So you
show
don't have to think about like setting up some wallet dependency or like
no,
CLI
there's no wallet
dependency.
dependency. But there are issues with this key store crate that we made. Like it currently only uses ED 25519 keys, and we want to let it use all of the keys that are available in Prism, of course. So
Yeah.
I'll eventually get around to adding that.
Well, this is like version 0.0.0.
Yeah, this is like, I'm
one or
actually
something.
Expecting there to be issues during the stream
All
because
good.
this is the first time I've like used it or shown anybody live. But yeah, so REST build times take forever.
That's all good.
Expected, but maybe I can like poke through this while we're waiting. So yeah, we have our transaction type, create game, game ID string, drawing game, game ID string.
And this is
They
all
take
stuff
this.
you added with SDK.
Yeah. And then what happens is there is a transaction verification. So this is like independent of the state. So for example, this method does not help if you need to check if the game has already been created or something. This is more like, is this position a valid position? Or is this game ID non-empty? Is the type of stuff that you could put inside transaction verify. And it also, if signature verification is enabled, it verifies the signed transaction. So like, yeah, if you have it enabled, then all of the transactions have to be signed. That gets abstracted away from the user when you're using the command line, but yeah. And then in state, this is empty. So that we are fully free to do what we want with the state. But here is where it gets more interesting with the validating transactions and processing transactions, because this is where like I can see, okay, is it this player's turn? So is this move valid, or is the game finished, or have they won? Has someone won yet? And then actually apply that transaction to the state.
Like if someone tried to play in a game that didn't exist, it wouldn't pass the validation stage, and it wouldn't be processed.
We can test that in a minute. So if I go back here, fail to build. That's not good.
No, that's not fun.
Oh, I know why, I think. Maybe.
That's good, for sure.
Let me zoom out for a sec to actually be able to read these messages.
AirDrop updates is asking, hey man, how can I connect my wallet on the website? You can't, sorry. This is, no.
So no, that's actually a valid point. That we need to add like an easy way to connect a web server to it and be able to sign transactions via Kepler. That's something that we struggled with. I know what's happening. Sebastian ran into this earlier. Okay, we need to update the SDK, but there is something that I can do to like get this working right away. Let's see if that works.
Drop an L in the chat if you're feeling lazy.
If this doesn't work, I'm gonna cry. Let me do this is like just weird REST dependency problems.
I feel like this is kind of similar to when you were building the rollup. Like
I didn't save this. That's the problem.
We were hitting a bunch of funny errors.
Okay, yeah, it's actually that same type of stuff. So like we kind of found a small workaround, but I think I have to talk to Lumina team to figure out what is actually at the bottom of that. Anyways, while that's building, I guess we can already like start with the actual implementation.
Cool.
So the first thing that the way I like to think about this is actually starting in the state. So it's like, okay, now we have some transactions and we have to think about the state of the rollup. Normally in a rollup, and it's always sensible to do, but we're not doing it here, is to store it in a Merkle tree, because then you can have Merkleized state and you can actually make it into a ZK rollup, blah, blah, blah. But for this example, like in the previous streams, we're just going to be using like a in-memory store. And to do that,
so this will just like store it locally wherever the rollup's running.
Exactly. So we're just going to use hash maps. But first, I wanted to create a type, and that has to be a game board. So I have board, and this should derive cloning, and we need to be able to hash it because we're going to put it in a hash map. And this has a few fields. So one of them is the creator. This is a verifying key. So this is the public key. And then we also have like pub player, and that's the person that joined the game. That's another like verifying key. And then we have the board state, which is a array of 9 bytes. That's not correct. And then we also have like what turn it is. So that's just like it starts at 0 and keeps going up. And depending on if this is even or odd, it switches between the creator and the player.
Okay, and the creator's like the creator's player 1, player's player 2, right?
Yeah, exactly.
Yeah, cool.
So if I can steal your code from
easy.
your rollup, you have a very, very useful struct called winning combinations. And then this just says, okay, well, if a player has all of these fields, then they've won the game.
Yep.
And then we're going to add some methods to the board. So we want, for example, to be able to find out the winner. So this would return maybe, maybe not, maybe if no one's won, then it would not return a winner. So that's why it's an option. And it's going to return the verifying, like either the creator or the player.
Yep.
And then I just had, what is it called? Yeah, exactly. Copilot, write this. I'm checking, there's one more thing that we need to do. If A is not equal to 0, and so 0 is like no, sorry, let me go back a step. This state is an array of 9 U8s.
And that's the board.
Yeah, that's the board. Yep. And then if field is 0, that means no move has been made there yet. So here I have to check, okay, is the field 0? because otherwise it could be that it tries to say, oh, well, all of these fields are 0, so that means there's a when, but it just means that those moves haven't been made yet.
Right.
So we get like, for example, we loop through each one of these. This would be A, this would be B, this would be C. And then we just make sure that they're all the same player, because in this board state, there's going to be like 3 possible options. 0, a move hasn't been made. 1, the creator has placed a move there. And 2 is that the player has placed a move there.
Got it.
So we say if A is 1, then we're going to return the creator. Otherwise, we return as a player. And then if none of these match, so if it gets through the for loop without ever returning, then we want to return none, because it means there is no winner.
So it's a draw. Cool.
So it's a draw, yeah. Or not necessarily. It just means that the game has not been won yet.
Oh, true. Okay, because this is going to happen like every time there's
right
a transaction that gets processed, basically.
So let's see if this. Oh, it worked. Okay.
Yay.
So the reason that this. We need to clone the creator and the player. This is already an option, I think. Oh, one thing I forgot is that this has to be an option. The reason this has to be an option is because when you create the game, there's no second player yet. So it's none until a player joins the game. And then
otherwise it might just break for no reason.
Right.
Yeah.
So yeah, that compiles.
Well, I guess it'd be a reason, but yeah, not a good one. Cool.
Yeah. And then I'm going to add some more utility methods to the board. For example, is full. It means this is just going to return a Boolean, and Copilot is right here. It's going to look through every place on the board and make sure that all of them are not equal to 0. Does that make sense?
0 is blank. Sweet.
Yeah, exactly. And then we also have is joined. And this is like exactly this. So if player is set, so if this isn't none, then that means the game has been joined. That's another really simple one. And then the last utility I'm going to put here is next player, which is going to also return an option verifying key. It has to return an option because it could be that the player hasn't joined yet. And then here we're going to use like just basic logic about, okay, if we keep increasing the turn by 1, then that means that one player is going to always be like the even numbers and the other one's always going to be the odd numbers.
Yep.
So the way we do this with code is always by saying if self.turn modulo 2 is 0, that means it's even. Cool. Then it is the creator's turn. Otherwise, it's the player's turn. All right. Cool. Now that.
Wait, so in that case, the player plays first, or is the 0 move the first move?
The 0 is even, so the creator plays first.
Got it.
Which is kind of a jank workflow, which we'll see, because it's like, okay, first I create the game, then someone joins, and then I have to make the first move. But what we could actually do, if you're smart, is put the first move in the create game and join game. So then by the time someone joins the game, a move has already been made. Or maybe even just put it in the join game. Anyways.
Yeah.
So.
Is that it for the board?
That's not it for the board, because there's one other thing, and that is we want to be able to print out the board state. So you did this in an interesting way, because you have a function that does display board, but there's actually a trait in Rust which is called display. And so this means anytime you try to put it into a string, it will like automatically print it the way that you
That's sweet.
define it here. So I'm gonna copy paste it for time's sake, and then it's simple enough that we can just walk through it.
Yeah.
It converts the numbers, like a 0 is blank, 1 is X, 2 is nothing, and then this should never happen.
Yeah.
That's why it's a question mark. Wait, I might have to fix these imports. All right, so you can ignore like this. This is very scary, obviously, to anybody that knows nothing about Rust.
Yeah, I mean,
But if you just
a little face.
Yeah, but if you ignore that, then we're just saying, okay, it's going to
reformat.
Right. It's going to write the symbol, because this is a function technically, of each of the 9 positions on the board. Technically, like we should probably do this with a loop or something, but it doesn't really matter. And this prints out the board state anytime I try to put it into a string.
Cool.
So that's it for the board. Now we can actually do the state management. So this is really simple, because then it's just, we have a field called games, and then this is just a hash map from the game ID, which is a string, to the board. That's it. Now I wrote in the README file, so when we like upload this later, you'll see there are a lot of ideas for improving this, especially if you want to make a web application for it. But this is like the most simple thing we can do, so I'm going to leave it like that. And so we get some errors now that we've created this, because it's like, okay, well, now here you're trying to return the state, but you're not doing anything with games. So this is really simple. Copilot helps us out there. Just puts a new hash map. And then here we get to the meat of the actual like logic for the rollup, because this is where we're going to actually validate the transaction, make sure that it's a valid transaction, and then actually process it. So there are things that we don't need to worry about in state. For example, that the signature is valid. That's done in transaction verify. And then any other verification about the fields, like independent of the state, would also happen here.
Okay.
And I'll get to that. But like here, this is specifically validating a transaction against the current chain state. So that means I like will look in this games, and then try to what is it called? Make sure that it's valid according to that. So the simplest transaction is create game, because all we have to do here is we have to make sure the game doesn't already exist. So if self.games.contains key game ID, which this game ID is set from the transaction, we are just going to return this error anyhow. So anyhow is a Rust macro that provides like ergonomic error handling. If you're actually making like a rollup, you'd want to create your own errors, but this is the easiest way to just experiment. So here I would just write game already exists.
Sweet.
And then otherwise, so if that passes, then we're going to return okay, because it's not an error, it's okay. So then I have to import this. Hold on. And I don't know if this works.
Not an error, meaning it like shouldn't crash the rollup.
Yeah, exactly. Use anyhow. All right. So now we have to return, because not the last line in the thing. Anyways, so that's the transaction validation for create game. and we can actually like move to process transaction, because when you process a transaction, it first runs this, it validates it, and then it tries to update the state. So what we would do there is also very simple. We would simply say self.games.insert for game ID, and then a new board. So, and what goes in the board, the creator is the TX stands for transaction, and tx.vk is the signer of the transaction. So that's the creator of the game. The player is going to be none because nobody has joined yet. And then we have the state, which is just 9 zeros. So that's how you do that in Rust. And then I think turn, which should just be 0, of course. So we have to wrap this one more time. Self.games.insert, and then we're going to return an OK because everything is fine. Does that compile? Yeah.
Yeah, nice.
Except it doesn't like this because why? Because it shouldn't be a reference. All right, so now we have create game. Join game gets a bit more complicated because now we have to check like, okay, are you the creator? You can't join your own game. And other things, or yeah. So hold on, let me scroll up on my reference over here. Move ends up being the most complicated transaction type, but so what we first want to check is, does the game exist? If it doesn't exist, you can't join it. So Copilot helped us out there. If the game doesn't exist, then throw an error. Let's just add this so it stops complaining. And then the next thing that we want to check is, so now we know that the game does exist.
Yeah.
So we need to check if it's already been joined by somebody else, because if it's already been joined, you can't like
join again.
Yeah. So we need to get the board out of the state. So that would be done like this, game ID, and then we can unwrap, which means normally Git would throw an error if this doesn't exist, but we know it exists. Now in practice, you definitely should not use unwrap here, but again, for sake of simplicity, we're doing this like in a production thing. You'd use map error, and then give the user back an error that this should never happen. Please report this as a bug. So now we can use if board is joined. So if it's already been joined, then we need to return error, game is already joined. Otherwise, actually, no, there's no else there. And then there's one more case that is, like I said a few minutes ago, you shouldn't be able to join your own game. So for that, we need to say if, oh, wow, okay, cool. Maybe it's reading my code and my other stuff. That's why it knows this. Probably. But if the board creator is the same as the signer of this current transaction, it says you can't join your own game. So that's done. Now we have the validation for join game, and we can actually modify the state, which is actually even simpler than create game in this case, because all we're doing is setting a single field. So here we say we get it from the state, but we get it as mutable. So that means if you don't do this, then we can't actually change anything in it. But what we want to do is we want to set the player to not be none anymore. So now it's some, and it's the person who signed the transaction. So this sets it. And we do an unwrap here again because through the validation, we know that this game exists. So then join game transaction is now complete. And then comes the fun part, which is hopefully red irony there. That's actually kind of fun. I'm lying. So we need to steal some stuff from join game. Like for example, the game has to already exist if you want to move. And then if the board isn't joined yet, you need to say you have to join the game before you can make a move. Game must be joined before you can make a move. So there's the making sure that the game exists and that it's been joined, and you also need to make sure that it's how do I say, your current turn. So if it's not your
You
turn,
can't
you
make a
shouldn't be able
move
to
if it's
move.
odd or
Right.
even, and you're even.
Right. So we say let player is the next player. And we unwrap here because it's an option again. So at this point, we can unwrap because we know that the board is joined. If it wasn't joined, then this would return none and it would panic, which is not great. But anyways, we need to make sure now that the player that we just got, like the next player, maybe I should rename this to next player. If next player is not equal to the signer of this transaction, then we need to tell them it's not their turn.
Yep.
All right. And then we need to say, we need to make sure that the move hasn't already been made yet at that point. So position, the move transaction type contains position. If that position is not 0, that means somebody's already moved there. So we return an error saying it's already been taken.
Cool.
And then we also want to check if there's a winner, you shouldn't be able to make a move.
Right.
We don't need to check anything about it being full. Like that doesn't really matter because this covers that case. Like if there's still a place to move in, you should be able to make a move.
Yeah.
If well, that should not be there. If board dot winner dot is sum, that means there is a winner. Because remember, if there's no winner, we return none. Then we're just going to return game is already won. Oh yeah.
Nice.
So that's like the most verification out of the 3 methods. And you notice that we don't. Oh no, we do use a position mode. That's fine. Why doesn't it like this? Because that's the wrong type. So when you index into something in Rust, you can't use a U8. You have to cast it to a U size.
Interesting.
So that's what I'm doing there. It's because different architectures have like, for example, if you're on a 32-bit system, then it's going to want to use a U32
instead of U8
to be the max index. And so actually on our computers, this gets converted under the hood to a U64. So U64s on our machines are what are used as indexes and like arrays. And that's to ensure that if you're on like a 32-bit architecture that you can't index something that you can't actually reach, but
yeah,
that's a tangent. Maybe I should
good.
go on.
No, that's a good explanation. Thank you.
So now we need to actually process this move, meaning like we need to update the board state, we need to increase the turn. And this is done by, first we have to like in join game, we have to get the board as something that's mutable so that we can modify it. And then I'm going to try to ignore Copilot there. Now board.state is the like actual place where the moves are stored. So we need to set what is it called? Oh wait, that's actually better than the way I wrote it. Does that work out? Let me think about this. So if the board turn is 0,
yeah,
then it's going to use player 1. If the board turn is, let's say 2, that'll first part it's 0 and 1. Otherwise, it'll be 1. Yeah, that works. All right. Do you understand?
Kind of.
Or
Not.
should
I
I?
think. Can you explain actually?
Yeah. So, like inside of this array of U8s, we have the three possible positions, 0, 1, and 2.
Yep.
If a field is 0, that means that nobody has moved there. If it's
Yep.
1, that means player 1 has moved there. If it's
Yep.
2, that means player 2.
Cool.
But we can derive that from the turn, which player is currently moving.
Got it.
Because like we see above, like we saw above, when the turn is even, that means it's player 1's turn, and when the
Yep.
board is odd, it's player 2's turn. So this is like, if it's even, then this part goes to 0 always. So like even if it's turned 64, this part goes to 0, and then it'll add 1. Now if it's an odd turn, then this part evaluates to 1, so this whole thing evaluates to 2. So then we get the possible outcome 0, 1, 2, and it's correct. I guess we'll see when I'm testing this if it actually works, but I'm pretty sure it does.
I guess. Yeah, I understand. I'm a little confused about where that gets used, but I think you're about to do that.
Yeah, well, so the reason we're doing, you mean like why we're doing this line?
Yeah, like what does this accomplish as a whole? I
Okay,
guess I'm a little.
yeah.
You can
Okay,
tell
no,
I
yeah,
kind of lost. Yeah.
no, it's fine. So this method that we're writing right now is to process the transaction.
Yeah.
What that means is that we're taking an incoming transaction and we need to update the state. Our state is like a bunch of game boards.
Yeah.
So if somebody is doing a move transaction, that means we need to update the board to include their move. Because
Oh,
otherwise,
okay.
like the board will always just stay zeros.
Yeah.
So that's why I'm setting the position from the transaction to the
Oh. Okay.
user
So
that
it's
is doing.
setting either 1 or 2 basically
Yeah,
based
exactly.
on the number of the
Yeah,
turn that it is. Yeah, no, I'm totally clear
exactly.
now. Thank you.
And then this is where that cool display trait comes in, because now I can just do this, print line board, and it will use that fancy formatting that we made where it actually prints out like the board. And yeah. So, but I want to add in maybe like, I wanted to show the game ID as well. So this means that anytime a transaction is processed on the rollup, it's just going to print it in the logs, like what the current game state is. We have to return okay.
Does that happen, I guess, even if there's an error?
No, if it
Oh, it
it,
wouldn't
it
process.
would print out if there's an error. So like we get a log in the rollup if there's a transaction processing error. Where was I? Oh yeah. So I guess we print it out and then we want to check if there's a winner. Does that work? Yeah. So this is like, here's some rest syntax. You can say, instead of saying board winner is sum, you can say let sum winner, and then it sets this variable to the winner if it is sum.
Mm-hmm.
So this is just saying, okay, well, if board.winner gives us a winner, then we can print out that they win.
Yep.
I don't actually think we can do this though, because that would be very ugly. Because we're printing out like a public key. So I'm just gonna say game has been won, and then remove this, and then actually.
Could
That
you
just
just put
means,
like player 1 or player or like creator or player maybe?
yeah, we
Or is that also
could.
ugly?
No, it's not ugly. We can also do that. So let me get this back there. So we could say oh, yeah, perfect. Okay, Copilot did it for us. So
Did
this
it
just
hear me?
says,
That's freaky.
Yeah, I know, right? So if the winner is the board creator, then the creator is player. Cool.
Nice.
And then if the board is full, then we'll print draw. And then there's one more thing we need to do, and that is to increase
Turn.
the turn by 1.
Nice.
All right. So I think that is nearly everything. There's only one more thing I want to do, and that would be that in TXRS, we have this verification that we do nothing with. So first of all, I don't want to do anything for join game, create game, because it's like, you could check, okay, is game ID like a non-empty string? But that's what you should do probably if you're like actually making this. But it doesn't really matter and waste time. So I'm also going to ignore that for the move transaction. But what I do want to check here is that the position is a valid, what is it called? Like if that it's between, 0 and 8, or that it's one of 0 to 8, because otherwise it's a move that's outside of the board, and then the actual transaction processing is gonna
Is it
freak
less
the
than
fuck
8?
out. No, because we start at 0. So there's 9.
So is it if position less than 8?
Oh, wait, no, it needs to be greater than or equal to 8, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8. No, if it's greater than 8.
Oh,
If
okay.
it's greater than 8, we need to return an error.
Yeah.
So we say return error anyhow.
I guess you could do greater than or equal to 9, but this
Yeah.
works. Yeah.
And that, yeah, that would also work. So that's all I'm going to do there. That's like, and so this is what I mean when I say, like, this is where validation happens that doesn't care about the state, because the position has to be validated regardless of what the actual state of the rollup is. And for this rollup example, it's very simple because we don't actually like use any interesting types in our transaction. We just use a string and a U8. But if you had interesting things in here, you would have to do some more interesting validation. But that's it now. And that means that I can like do my demo.
Oh shit! Is that? I guess that's the whole roll up then, right?
Yeah, this is a whole rollup. It's literally like, so we made these with the command line, and then we just implemented like what happens for each of them.
Yep.
And so this was my whole goal with making this SDK, was I was thinking like, I don't want to have any features in a rollup SDK. I just want something super simple where like I just have to fill out, verify, and process.
Yeah, it kind of like gives you the template at least to basically implement like your custom logic on your own, instead of like being opinionated and like giving you those as examples. Yeah, nice.
So let me zoom in here, and then I can start showing you. This does not seem right. Okay. So the first thing that I want to showcase is like the creating signers. So if I say tic-tac-toe create signer P1, now I have a new random private key inside of my macOS keychain. Nice. It should technically work on Linux, but I need to try to run it on a Linux box. I'll also create signer P2. So now I can run my rollup by simply saying that's incorrect, tic-tac-toe serve.
Damn.
Oh, wait. No, I'm not done. It's connecting right now to a very old Celestia chain that's local, so it would have to do a very long historical sync. So what I'm going to do is, if you use our Shard-SDK repo, this is called Shard here locally on my computer because that's the old name, but it would be Shard-SDK on your computer. Then I can just say just Celestia up.
What?
And that's gonna launch a local Celestia network on my computer.
Yo,
that I can
Diego,
talk to.
check it out. That's sweet.
Yeah, so I gave this to Diego. Like, this is actually made by Lumina, and Prism janked it. But
I had
like,
no
this
clue.
is the
This is
easiest
awesome.
way to like launch a local network for us. So now if I do it, Tictactoe serve, and I'm going to zoom out a little bit because it's a bit.
Oh, good.
So we have really fast blocks here. Like, I guess it's like, seems like every 1 or 2 seconds. But you can see, like, first it did a historical sync from heights 1 to 12,
Yeah.
and then it started processing the incoming heights.
I like these logs. They're actually like very useful.
Thanks. Yeah, when I was like making the SDK, I was looking at, of course, the examples we did in previous streams, and there was all print lines, and I was like, I really need to fix this logging. So, yeah.
Good stuff.
So will Tic-Tac-Toe work from here? Yeah. All right. So the way that you can send transactions is I would simply say tic-tac-toe, submit TX. And now this transaction I want to be sent from player 1. So I'd say key name P1, and let's create, what was it, create game?
Yep.
So then create game. Now it ends up converting the case. So instead of like capital C, capital G, it converts it to, this isn't called camel case. What is this called? I forget.
Kebab.
Whatever. Yeah. Kebab case. Create game. What's the game ID? Maybe just like test game. Transaction submitted successfully.
Nice.
So if I try to run this again,
It's gonna be
it's
like,
going
dude.
to tell me, hopefully.
Oh. Is there a chance that maybe it wasn't picked up already?
No, I know what's happening. I have to recompile the rollup. We wrote all that code and it's not actually running.
Didn't compile. Yeah, that makes sense. Because what should have happened is it says the game already exists. You can't make it again.
Yeah, exactly. So I'm actually going to do just.
And now you're shutting down. Or just
Yeah, so if
by running that again, does that just overwrite
it
the
takes it
existing one?
down. Yeah.
That's fresh.
There's also like just Celestia down if you don't want to start a new one. But
nice.
Anyway, so we can do serve, but it's not up yet. Now it's up. All right. So let's try that again. Create game test game. And now it's going to ask me to enter my keychain. It does it twice for some reason. I haven't figured out why. But now transaction submitted successfully. Batch posted with 1 transaction. Nice. So now this should hopefully return an error. Game already exists. Perfect.
Nice.
So now if we want to have player 2 join the game, I simply just make this P2 join game, test game. It's going to ask me for player 2's. All right. So now we join the game. Now we should make a move. Now, wait, maybe I should try this again.
Try to join the game. Yeah. Nice.
So now we can try to make a move from player 2, and I think it should say that the creator has to move first. So move test game, let's just set like the top left, so 0. Not my turn. Perfect.
It's working.
Player 1, hopefully, when it receives it, test game.
Nice. Hey.
So then now it's player 2's move. And so I say player 2, move, test game, 0. Oh, position already taken. So
nice.
we're going to say 0, 1, 2, 3, 4. Middle is the best, right?
Something like that.
Yeah.
I mean, you're going to win either way, so. Well, actually,
I don't know. I don't know if I'm going to figure that out.
Yeah.
0, 1. I want to get over this as soon as possible. Player 2, move, let's say 5. and then player one.
Damn, this is quick.
Let's just win the game.
Yeah.
Yeah, because on a local testnet. If you used Mocha, it would be a little bit slower. I want to add docs for like how to connect it to Mocha instead of using the local testnet.
But there's definitely a lot of value in being able to just test something this
right,
quickly
exactly.
and not wait on it.
Like,
yeah.
Game has been won by creator. Woohoo!
Yo, that's awesome.
I have like a few. What is it called? I guess that's the end of the demo. But
Yeah.
there are a few things that I'd like to talk about. So
Like
one of
improvements,
them,
basically.
yeah. So this is like available in the Shard-SDK repo. There are a few things. One of them, nonce control is not implemented. Replay text can occur. So I've enabled signature verification, but the issue is that like without using the nonce, then if you make a move, I could go steal your blob and then like replay it.
And basically like know what
but wait,
is.
it wouldn't. Would end up like actually not being important. So this rollup does not need nonce control because each transaction can only be run once. But if you had something where, like, let's say it's a chat, and you're sending a message in a channel, then if you don't implement nonce control, what would happen is you would be able to have people like steal other people's messages and then keep posting them because you're just posting their transaction over and over. Like you need to make sure that this thing gets incremented. So by default, this is always 0. The way that you would do this is by like having in your state like nonces, like maybe a map from verifying key to nonce, and then every time you verify a transaction, you make sure that it's the user's next nonce. So it would work the same way like in other blockchains where the transaction is only valid if that is the transaction with the next nonce for your account.
Right.
And you would do that simply by passing here -s nonce for something. There's probably better like ways to do this.
Yeah.
But this is the simplest way to implement it on my side. And then, so yeah, nonce control is important for some rollups. Another big important thing is what we did with Greg Chat was we added our own command types, like a read channel. Currently, like we don't have a guide for how to do that, or for like adding web, like web API requests. But we're going to add examples that do this. Sebastian is working on making Greg Chat right now. But like that would allow you then to have a web interface over this. And what that would look like is that you essentially put more things into this file. So then anything here could be a web request. Right now, there's only one like available web endpoint, which is submitting a transaction. And if you did that, you could like have a web interface for this where you could like list all the games, let people join games that are unjoined. You could watch other people's games. You could get your user stats, how many times you've won. Then I have just other stuff like you could have a username registration so that public keys aren't used, like we had in Greg Chat.
Human readable.
And then and then maybe like passing in a game ID is dumb. Maybe it should just create one and then you give that to your friend.
So you don't even have to deal with the like test game being made already.
Yeah. And then create game would take nothing. It would just be like an empty transaction, basically.
Nice.
And then it would like give you a new game ID. Yeah. So that's it.
Yeah, that's awesome. I guess I'm actually want to go back to the replay attacks because I'm kind of I guess a little blurry on that still.
Yeah.
And I think maybe some other people might be too. So basically you want to keep, like in this case, you said it doesn't matter.
Yes.
And why is that?
The reason it doesn't matter is because by nature of our rollup, we basically already have a nonce. And that nonce
because
is
it's like the turn, right? Okay.
Yeah. So that has to keep increasing. And like now if we didn't have game ID, if it was simply like, oh, you you set up a player to like always only be playing one game at once, then replay tax would become an issue because there could be a case where you take somebody's turn from a previous game and then send it to Celestia again, and that transaction would be valid because they signed over it, and like all the fields are valid. But because we have the turn thing and we have the game ID, you can't like take somebody's old transaction and send it to the chain again and have it pass.
Because it won't be validated.
Right. Now,
which means it won't be processed.
Right. For sake of like explanation, we could say, let's say we have a token on here and we're like, send tokens to receiver. The receiver could be a verifying key, and then an amount as, I don't know, U64. All right. Now, what would happen here if we did not have nonce control, or if you don't implement it, is that I send you some tokens.
Yep.
And then you go look at my blob on Celestia, and you simply post my blob again, like, and it has my signature, so I've signed over it, and it would send you some more tokens.
Got it.
Now, if you have nonce control, that means that this would start at 0, and then the next transaction they send has to have 1, and 2, and 3, and 4.
Cool.
That this is always increasing, then you would not be vulnerable to that attack.
Because it would realize that the nonce needs to be +1 from whatever it was. Cool.
Right.
Yeah. Thank you.
No problem. Yeah.
Thank you, Ryan. That was sweet.
No problem. I guess I'd like to just end this on the note that what we'd like to, the kind of end goal with this, or the end game here, is that I have a ZK template, and then you just generate your rollup, you write the logic, and then you can have, like, it comes with a browser light node that verifies those ZK proofs in your browser. And then you can have a fully decentralized app. Now, that's like blocked on a few things from Lumina side, and but like that's the goal. And eventually we'll also integrate Prism fully, so that if you like have some need for identity management, you can integrate with Prism very easily. But
so
this
then you wouldn't
is like
need to use like the MAC key and stuff like that. It would just be universal.
Well, you could, yeah.
Well, I guess you could use Prism
the same
with
identity.
the MAC key.
Well, the idea is more like, let's imagine that a ton of people make rollups with Shard-SDK. Then you wouldn't have to register on each rollup. You could simply just always use your Prism identity across all the chains without needing to like register.
Beautiful.
So this is the simplest way to make a rollup today. That like works. Obviously, yeah.
Sorry.
No, you're fine. It's not feature complete. Like, there are no features because there's no bloat. It's kind of the whole point of it. It's not meant to be used in production, but if you just want to experiment with some cute little idea, this is the easiest way to do it right now. And so we're going to try to like put some docs around this and get some more examples in, so you can play around with it yourself. But yeah, sorry for the infinite.
No, you're good. I was too late to turn your screen off.
No, I was pretty quick there.
We had a question in the chat from Captain Majid. And we actually have two from them. What is and I feel like we should have gotten to these sooner, but I didn't want to interrupt you because you're in the flow. But what is a rollup in this context, and what is Shard-SDK? I know of rollups like Optimism, etc. What part of rollup is this? And if you could explain Shard-SDK compared to Cosmos SDK.
All right. So
there's a lot to unpack there.
That's like, there's many questions here. So the type of rollup that this creates is something called a base rollup, which means you do not have your own validator set. You don't have your own sequencer. And these are things that make existing rollup frameworks extremely complicated and have a lot of logic and complexity and features because they are important for financial applications, and it's kind of like the Ethereum way of doing things.
Yeah.
But there's this new paradigm called base rollups where you let Celestia validators sequence your transactions. And that's what this is. So if you were to compare it to like Cosmos SDK, Cosmos SDK is a very, very big thing that does a lot. And it's very powerful, but it also requires a lot of knowledge to even make a basic rollup. The idea behind this is that you can make a rollup, a very simple rollup, without needing to know all of these details about how they work and worrying about validator sets or deployment, things like this. And then I think you also asked a little bit after this if we can plug in Comment BFT, and no, because Comment BFT is a consensus engine, and there is no consensus here because Celestia validators have the consensus of your transactions because Celestia is the thing that's sequencing your transactions. So we can
basically, as long as it gets
scrap
posted,
that entirely. Like we don't need it because base rollups are that simple architecturally. Now, there are downsides to this. For example, like it's really difficult to make your own token or something in this framework. So if you're wanting to, like, I don't know, make a token, make some money, like have validators, and you're like printing tokens to secure your validator set, that's obviously very economically complex, and we can skip all of that. But it also means that we don't have a like built-in way to manage tokens or to like have governance over your chain or something like that, like other SDKs provide. But you could, and this would kind of be funny, you could like plug in the EVM or something, or the SVM, because all you need to have is like verify transaction and process transaction, and you could simply like plug in an EVM there, and then it's like, okay, is this transaction valid? Let me ask the EVM, and then process it by using Reth or something.
Interesting.
I don't know.
So you basically just use like EVM logic to, I guess, like validate and process the transactions, but like you wouldn't have all the other. I guess would you? Yeah, I don't know.
Stuff and complexity around that, exactly. Yeah. So if you think about it, what we just wrote, my state and TX file, like that is my execution environment. So in this modular ecosystem, we talk a lot about, oh, what execution environment are you using? And like there's a ton of them spawning up everywhere. A lot of them are EVM based, but they're all very complicated. And my execution environment for Tictactoe Rollup is a few lines of Rust. I don't need all of that baggage, and I don't need to like debug a ton of stuff. It's very, very simple, very, very minimal. But if you wanted to, you could use one of these complex execution environments by just filling out Shard-SDK's interface.
That's sweet.
Yeah.
I didn't realize you could use it with, I guess, other like execution environments.
Yeah. I mean, you could.
Instead of making your own. Yeah, I mean, it sounds like then you get to the point where you have like this massive framework that has all these dependencies that you might not need.
Yeah.
Cool. Well, thank you again, Ryan. We'll go ahead and add the Shard SDK in the description of this, but I'll put it up there again if you're watching and you want to check it out. That's all I have. Thank you again for showing us how to build Tic-Tac-Toe as a proper based rollup. And
thanks for having me.
Yeah, we look forward to, or I look forward to seeing you in a future stream, but also seeing everyone else in future streams as well.
Yeah. Is
I guess,
finality on Celestia? Yes.
yeah, one more question.
So
Yeah,
the way bits
so
rollups work is that I do not produce blocks. I simply post my transactions to Celestia. The Celestia block is my block. So if when that block is finalized, which Celestia has single slot finality, my rollup block is technically also
final.
Because
Yeah, and there's no need to like,
as the full node, have to process all of those transactions in that Celestia block that are for my rollup.
and there's no need to like wait for like multiple block confirmations or anything like that. With single slot finality, basically once it's included, it's final. So like there's assumptions that you'd have to, like you're making assumptions by saying it would happen within 6 seconds, but with 6-second
Yeah.
blocks, you do have like basically 6-second finality.
Because fuck preconfs.
Yeah. Mark this not for kids. Okay.
Oops.
No, I'm kidding. Anyways, thank you for the questions. Thank you everyone for joining. And Ryan, thanks again for hopping on. No worries. We didn't even plan this really. So thank you for showing
No,
up.
it was
Majid.
impromptu.